Hello and welcome to Pre-Calculus Lesson 6. Today we are covering fractional equations, radical equations, and systems of three equations. So let's get started. You may be asked, in the event of an emergency, no, just kidding. You might be asked to solve this type of problem. I was going to totally go the whole airplane talk. If your oxygen mask falls, put yours on first. It's an excellent picture of we have to have our lifeline attached first, right, with the Lord, before we try and go out and help others and do a million things. Like, we want to have that relationship, the upward relationship, right, first. Anyways, wasn't planning on covering that in this class, but anyways, we are solving this equation. Now, as much as we love fractions, we don't love fractions. They're difficult to work with. So what I would recommend is you multiply by the least common multiple of all of the denominator so that you get rid of those terms. So it looks like my least common multiple is 21x plus 2. Remember, you have to multiply things in order to get the least common multiple. Multiply. Got it. So I'm going to multiply by 21x plus 2. I have to multiply everything by 21x plus 2. Otherwise, I am unbalancing my equation. Now I can cancel some of these because obviously that's why I'm doing this. 3 and 21 cancel to make 7, and 21 and 7 cancel to make 3. From there, I can multiply this out. So I get 4 times 3, which is 12, x plus 2, plus 3 times 21 is 63, equals 35, x plus 2. From there, I can solve this equation as I always would. I'm going to get all the x's on one side, all the numbers on the other side. I won't belabor this too much. You guys are in pre-calc and can figure this out. Subtracting 35. These are nicer numbers. I'll subtract 12. And I'll subtract 70. So 63 plus 24, 60, 70, 80, 7 minus 70 is 17. 35 minus 12 is 37. Oh dear. 23. Wow. So x equals 17 over 23. Ugly? Yeah, but not impossible. For nothing is impossible with God. True story. All right, now we're going to do systems of equations where we have more than one variable involved. So let's do 3/7 x plus 2/5 y equals 11. Oh, in fraction or in decimals. Okay, the big thing here is we want to get rid of all the decimals and we want to get rid of all of the fractions. So to get rid of the fraction, I'm going to multiply by the least common multiple, which is 7 times 5, which is 35. A lot of people forget to multiply the 11 by 35 because it doesn't have a denominator, even though it does, of 1. But people forget that and they usually get the problem wrong. Now, how do I get rid of these decimals here? Well, if I have 2 decimal places, I know that I have to multiply by that number of zeros. So in this case, 2 decimal places, 100. Now, can I multiply this one by 10 and then this one by 100? Because I only need to get rid of 1 decimal place? No. Everything you do to one side of the equation, you have to do to the other side. And since we're multiplying everything by 100, I have to multiply by 100. So pick the largest number of decimal places that you have and multiply by that number. So up here, I'm going to cancel. 35 divided by 7 is 5. 35 divided by 5 is 7. And we'll leave that. So 33 times 5 is 15. X plus 2 times 7 is 14. Y, 11 times 35 is 385. In this equation, I have 3x minus 20y. Important here, 0.2 times 100 is 20, not 2, equals negative 370. From there, you can use substitution or elimination, your favorite method. I would encourage eliminating the x, but time will... I ain't got time for that. But you guys can do that quickly on your own. So moving on. Now let's talk about radical equations. So we have the cubed root of x minus 5 minus 2 equals 2. Now, I'm going to give a word of caution. Anytime we have a square root or a cubed root or whatever in the equation, we have to go back and check. So I'm going to make a little note for myself down here that I have to check it before I'm done. Because sometimes when you square or cube or quadruple, take to the fourth power, a square root, you could potentially, and you are, adding solutions. So you have to make sure that the solution you get at the end wasn't just added and doesn't work in your original equation. We'll see that in a second. So the general process for these is you're going to isolate the square root or cubed root. So I'm going to add 2 to both sides. So that gives me the cubed root of x minus 5 equals 4. Then I'm going to get rid of the radical. In this case, in order to do that, I have to cube both sides because it's a cubed root. On the left side, I'm left with x minus 5. On the right side, I'm left with 4 cubed, which is 64. So x equals 69. Now, I made my note that I have to check. So I'm going to take 69, I'm going to plug it in up here. The cubed root of 69 minus 5 minus 2, does that equal 2? So I'm going to kind of put that question mark there. Just like we did with the trig inequalities, we just don't know. So question mark. 69 minus 5 is 64. The cubed root of that is 4 minus 2. That does equal 2. So it checks out. Now I can square my answer. If you don't do the check, you'll probably get it wrong because they put a lot of tricky ones in there. There we go. And also, I will take off points because you did not check. So please do the check. Alrighty. Let's take. Oh, we already did one of those. Ooh, this one's ugly. So we have the square root of x minus 48 minus the square root of x plus the square root of x equals 8. So my first step is going to be to isolate the radical. Unfortunately, I have 2 of them. So I'm going to isolate the most complicated one. So that means the square root of x minus 48 stays on one side, and unfortunately I get 8 minus square root of x. I am still going to go through the same process again. I'm going to square both sides because I want to get rid of the square root. And so that gets me x minus 48 equals this squared. What is this squared? Well, if you remember our formula, a plus b squared, that's a squared plus 2ab plus b squared. If you don't remember that formula, you need to know it, okay? So 64 minus 16 square root of x plus x. Now, oh dear, nope, that's good. Luckily for me, I can now isolate and restart this whole problem by isolating this square root of x. If I subtract x from both sides, these go away. I can subtract 64 from both sides. So that looks like negative 112 is negative 16 square root of x. Let's check and make sure we're doing this correctly. Yep. So now I'm going to divide by negative 16. Square root of x equals 7. If I square both sides now, to get rid of the square root, x equals 49. I didn't check. I have to come all the way back up and check. If I don't show this step, again, I'm going to lose points. And by me, I mean you. So we have 49 minus 48 plus the square root of 49, question mark, 8. 49 minus 48 is 1. The square root of that is 1 plus 7. That does, in fact, equal 8. So this is correct. Check. Alrighty. Last part of our lesson is that we are going to have systems of 3 equations in 3 variables. That's fun. All right, so in these problems to start out with, they're going to kind of give you, they might give you some easy ones. In this case, you can solve this using substitution, or you can solve this to get x equals 2y. Substitute that into these two equations. Again, this is all about being diligent. So as a believer, in everything that you do, you kind of have to do things above board. You have to do things above reproach, the Bible says. My encouragement to you is just take your time. I know you want to fly through your math homework and be done. These are problems where you really need to take your time and make sure you're doing it correctly. So I solved for x equals 2y. I'm going to plug that in when I have x here. This is one where I would highly encourage showing all of your work because they're just so easy to mess up. Four y plus 2y is 6y. 6y plus 3y is 9y. From here, I can do elimination. So if I add these two, I get 15y equals 30. So y equals 2. If y equals 2, x equals 4. And from there, I can plug it into one of those equations. Uh, 8 plus 4 is 12. If I subtract 12, z is negative 2. Now, I can't leave my answer like this. I need an ordered triple. So my answer is going to be 4, 2, negative 2. When you get more complicated ones, you're probably just going to have to start off with elimination. And that is problem set number 6.